Good evening, everyone, and thank you so much for tuning in for tonight's event. My name is Frédéric Barthelet. I'm part of the organization team for Serverless Days Paris 2023. And tonight is the third warm-up session of this year's event with Mete Atamel. We'll jump right away into that, but just a few words before we begin with today's agenda. If you don't know yet, Serverless Days Paris is an event dedicated to serverless technology that happens in two ways: a few warm-up sessions, completely remote, that you're currently watching, and a main event on June 7 that will be hosted at La Bellevilloise in the 20th district of Paris, for which you can still buy your ticket if you want to join and have a lot of awesome speakers from around the world share their knowledge with you. You can go on paris.serverlessdays.io to learn more about the agenda of the event and to get your tickets. I'd like to take the opportunity as well to thank the sponsors of Serverless Days Paris 2023. Thank you very much, Theodo, AWS, Cloudflare, Serverless Guru, Algolia, Fastly, SmartDSI, and Programme. Sponsors are the reason why this kind of event can happen, and I couldn't be thankful enough to them to make sure that this year's edition is a great edition. Tonight's agenda will be split in two parts. First, I will bring Mete on stage to deliver his talk about service orchestration pattern. And then we will have a roundtable discussion with Mete and Olivier Leplus during another 30 minutes to answer any questions that you might have. So please do not hesitate and use YouTube and LinkedIn chat to ask your questions and to discuss a little bit about the topics that Mete brought up during his talk. That's it for me at the moment. I will now bring Mete to the stage. Just a small introduction about Mete. He's a developer advocate at Google, currently focusing on helping developers with Google Cloud Platform. He's a long-time Java and a recent C# developer, and he likes to compare the two ecosystems most of the time. Before Google, he was working at Microsoft, Skype, Adobe, EMC, and Nokia, building apps and services on various web, mobile, and cloud platforms. He's originally from Cyprus, and is currently living in Greenwich, not too far away from the prime meridian. No, Mete, the stage is yours. I will leave you to your talk, Service Orchestration Pattern. See you later.
Cool. Thanks, Frederick, for the awesome introduction. And hello, everyone. Thanks for being here. I actually wanted to speak at Serverless Days next week, but unfortunately, I had a knee issue, so I had to get a knee surgery done. And the organizers were kind enough to give me the stage remotely so that I can at least talk about the topics I want to talk about. So yeah, I want to talk about service orchestration patterns today. Before we get into the patterns, first I want to talk about what I mean by service orchestration. What are some different types of service orchestration, different service orchestration styles that you can have? What are their pros and cons? And then once we cover that, then we'll get into the patterns and talk about some of the things that I've seen here that helps when you're thinking about service orchestration. My slides are already on speaker deck, so if you want the slides, this is the link, and I'll share this at the end of the presentation as well. And I might skip some slides towards the end because I only have 30 minutes, but feel free to check the whole slides if you like. All right, so first, let's talk about service orchestration. What do I mean by that? And talk about some different styles that we have in service orchestration. Now, first of all, service orchestration tries to answer this question. How do you organize a group of microservices to cooperate towards a common goal, right? Of course, in this question, I'm assuming that you already went through the phase of breaking down your monolithic application into microservices, and you're already running in microservices. Of course, there's a lot of discussion in that space right now where people are saying that, okay, maybe it wasn't a good idea to break monolith into microservices. Maybe we should go back to monolith and so on and so forth. I won't get into the discussion in this talk. I'm assuming that you're in this microservices space. And once you're there, like you are kind of trading one problem with another problem. Like, so you got rid of the monolithic problems, and now you have the small microservices. But then you need to kind of think about, okay, how do I get these microservices that are independent kind of work together? How do they communicate? And if something goes wrong, what do I do? So you have that kind of problems, and that's what service orchestration tries to answer. And you have some choice in there. So let's say you're building a very simple e-commerce application where people buy things, and in this e-commerce application, you have some services. And of course, here I'm simplifying a lot. I know in a real world kind of application, you have much more complicated architectures. But just to show you the options, let's say you have a front end that's running on App Engine on Google Cloud. Then you have a Cloud Run service for payment processing, which is a container service. Then you have a shipping function, and then maybe you have a notification function, right? So let's say you have these 4 microservices. And one easy way of getting these microservices kind of cooperate is making them call each other directly, right? So the front end knows that there's a payment processor. So when it receives a request, it will do its part and call the next service in the chain. Then the payment processor service will know that there's a shipping function afterwards. So it will do its part and then call the shipping function, and so on and so forth, right? So this is a direct service-to-service call. Now, when we look at this direct service-to-service calls, the pros is that this is very easy to implement. This is very easy to explain to someone. Services just call the next service in the chain. There's not much complexity. On the other hand, you are creating coupling between your services, right? So each service now, it needs to know the next service in the chain, and that creates this unnecessary coupling. Because if you need to change the service, then you need to think about, okay, who I need to call. Maybe it has implications for that service, and you probably also need to think about who's calling you as well. Like if you change something about your service, maybe someone who's calling you might need to change as well, right? So there's already too much coupling by having these direct service-to-service calls. Secondly, let's say a service in the middle kind of fails. That becomes a single point of failure. Then the whole chain breaks, and that's not a good kind of architecture. Now, each service is doing its own business logic, but they also need their error logic, their retry logic, their timeout logic. If you call a service and you don't get a response, you need to think about what to do. Do you retry? And if you retry, how many times? Or if you wait, how long you wait, right? So that logic, which is not really your business logic, but more about the resilience of your service, you need to think about those, and you need to implement them in each service. And now you have transaction, this checkout transaction spread across different services. So it's not a single place where you are applying this transaction. For example, like in a database, you have database transactions where you apply multiple operations in a transaction. And if something goes wrong, you can unroll the transaction, right? But you can't do that here because you have this transaction spanning multiple microservices. And if something goes wrong, what do you do? Like, who ensures that the transaction is successful? And there's a pattern called the Saga pattern, by the way, that can help here that I will talk about in the pattern section. So as you see, this direct service-to-service calls, they're easy to implement, but they come with a lot of negatives already. So what can you do? Another option you can take is use events. So let your services communicate indirectly via events. And the way this looks is that you still have your services independent, and you still have your front end receiving the request from the users. But then when the front end receives the request, it does its part, and then it will emit an event. This event is probably something like order received event, or maybe order process event. So it will emit that event to a message broker or event bus, or whatever you want to call this backbone. And then this message broker will look at that event type, order processed, and it will figure out who is interested in that event, the payment processor, and it will pass that event to the payment processor. The payment processor will do its part, then it will emit its own event type, payment processed, and it will send it to the message broker, and the message broker will do the same. So it's still the same kind of chain, but the key thing here is that the services, they're independent, they don't know about each other, they don't call each other directly, they're just communicating kind of indirectly using events. And if you look at cloud providers, like Google Cloud has PubSub Event Arc services for this. AWS has SQS, SNS, Event Bridge. Azure has Event Grid, Event Hubs, Service Bus, things like that. So no matter where you are, and also there's open source projects like Kafka and RabbitMQ and others. So there's a lot of choice here when you want to use events. So you don't need to build your eventing system. You can use whatever is available to you, whether you're running in the cloud or you're running yourself with open source technologies. Now, the pros and cons of events is that, first of all, the pros is that your services are loosely coupled. They don't know about each other. They don't call each other directly. And that's a good thing because that enables you to change these services independently. Services can be changed, scaled independently. I already said this. So if you need to change payment processor, you don't really need to think about anything else. As long as the event format doesn't change, then the service can change however you want. Like, you just need to pay attention to the actual event formats. You don't have a single point of failure in the sense that if a service goes down, its queue will probably start backing up. So it will have more messages in its queue, but the rest of the services will still send messages and it will still receive messages, right? So maybe your transaction won't be complete, but part of your system will continue to work. So, and maybe that's okay. For example, let's say the notification service is down. Maybe it's okay that the rest, you finish everything else, and maybe it's okay that you notify the user later. Like, it doesn't have to happen right at this minute, right? So there's no single point of failure in that sense. And events are very useful when you want to extend your system. If you need to add a new service, you just deploy the service, configure what kind of events it needs to receive, and that's it. You don't need to touch the rest of your services. On the other hand, now you're dealing with different event types and all these event types flying around. So when something goes wrong, it's usually difficult to monitor. It's difficult to kind of figure out where things went wrong. You usually need to kind of look at your message queues, see which message queue is backing up. Then from there, go to that service and then look at the logs and then try to figure out what's happening. It's not like you wouldn't know right away that one service is not working because it could be anywhere, really. The errors and timeouts are still hard, and you still need to think about them. And the business flow of your application is not captured anywhere. The event-driven architecture is almost like, this business flow is almost like a side effect of your event-driven architecture. If someone asks you how should the calls flow in your system, you probably cannot point to a place and tell people, okay, this is how it should work. And I will show you that in orchestration, this is actually captured and it's very useful. And this problem that we had before, the whole transaction being successful and who ensures that, it's still a problem. You need to think about that. And let's imagine a more complex scenario. So, usually when you are doing some kind of transaction, you read a database, then you check if you're in stock or out of stock. And depending on that, maybe you call a supplier API, then you update the database again, then maybe you use a third-party SendGrid to send a notification, right? So when you look at this flow chart, this is your business flow, right? It's very clear what should happen. You can just read the flow chart. But taking this and making it event-driven is not so straightforward. And then even if you make it happen, let's say you take this and make it event-driven services, you kind of lose this flow chart. And that's a shame because, this flowchart has a really useful information of how your business flow should work. But you kind of lose that by taking this and converting into an event-driven kind of architecture. So what can you do? Another option, a third option you can take is to use a central orchestrator. And the idea here is that, you still have your independent services, but you use an external orchestrator, an external service to call these functions or services. So what you do is that first you encode your orchestration. So you encode what should happen. So you encode the fact that first you need to call the payment processor, then the shipper and the notifier. And then when you receive a request, that you execute an orchestration. So the front end will execute orchestration. The orchestrator will receive that execution order and then it will look at its rules, and then it will execute those rules. So it will call the payment processor, then get the result, then call the shipper, get the result, and so on and so forth. And again, if you look at Google Cloud, there's workflows and Cloud Composer for this. There's step functions on AWS, Logic Apps on Azure, and open source stuff like CNCF service workflow, and long-standing business orchestration engines like Camel and Camunda and so on and so forth. So there's a lot of options here as well. And they all do similar things in a slightly different ways with slightly different angles. So they're not like apples to apples comparison, but I put them in the same landscape. And just to show you quickly how this looks in workflows, because that's what I know with Google Cloud. For example, let's just say you want to just change some services using workflows. I just want to show you a quick example, just a hello world, so you have an idea. So you first define your orchestration, and you can define it in YAML or JSON. But as you see, first, this is my main orchestration that receives an input here. Then I define my steps. So I have a step where I look at the input and see if there's a search term in the input. Then if so, then I use that input to go to next step, which is read Wikipedia. And then we make a call to Wikipedia with HTTP GET. We call that Wikipedia with the search term, and then get the result, and we return the result, the first result that we can get from Wikipedia, right? And if I don't have a search term, so if I'm here and I don't have a search term in the input, then I get the current time, and I extract the day of the week from the current time. And by the way, I get the current time by calling this time API, and I extract the day of the week, and I use that as my search term, right? So you see how you define your steps and call third-party APIs, and then you also get a visualization of how things should work. So this is very useful. I'm capturing my business flow and the flow of my application. And just to show you that this works, if we can execute, if I pass in a search term, let's say search term, and then let's pass in serverless. And if we execute this, then we'll see that these are the results that are returned by Wikipedia. And then if I execute without any search, without any input, it failed because I need to I still need to provide the JSON, so I need to do this. So if you execute again, now this will call the get current time, and then today is Thursday, so it will return Thursday things, right? So you see how we can put things together pretty quickly in an orchestration like that. So what are the pros and cons of orchestration? Business flow captured centrally in this YAML that I show you. And once it's captured, you can source control it, you can version it, you can do rollbacks, because let's say you deployed a new version, it doesn't work, you can roll back to the previous version. So there's a lot of benefits of being able to kind of centralize this business flow. Now you see that there's steps. So each step, in each step you do something. So if something fails, you know exactly which step failed. Like you know that this step failed, and you can go there and you can look at that service right away. Like, so it makes monitoring very easy compared to event-driven services. The errors, retries, and timeouts, you still need to do them, but you can centralize them. So you can apply the same error policy, for example, for each step if you like. And your services are still independent, so they're still independently deployed, but you kind of bring them together into a temporary orchestration. On the other hand, a new orchestration service is something you need to learn and maintain. Orchestrator can be a single point of failure. So if orchestrator is down, then nothing will work. So you need to think about that. And things are harder to change, because if you need to change something, you need to do, let's say you need to add a new service, you need to deploy the service, and you need to deploy your orchestration to use that service. So there's a couple more steps. And now, if your orchestration fails, you know which step it failed, but you need to think about how to handle that. So maybe you need to take a compensation step. If you do a step, maybe you need to unroll that step. And again, the Saga pattern comes into play here that I'll show you shortly. All right, so that was a really quick overview of what I mean by orchestration, what are your pros and cons and choices that you have. Now, I don't have that much time, but I'll try to go through these patterns really quickly and explain to you what are some useful patterns that I see in this service orchestration space. Well, first of all, this is not a pattern, but it's more like what you should do is that when you're designing an architecture, make sure you go through this choice of architectural style and make sure that you make that choice in a conscious way. Because I've been at places where the architectural style just happens, like someone goes with one way without a clear reason. And that's not a good way of doing it. Like if you're starting from scratch, try to think about what are you trying to achieve and which style fits better for what you want to achieve. For example, if you have a simple architecture with a handful of services that they don't change so much, maybe it's okay to go with direct calls, even though they have drawbacks, right? So maybe it's okay. Like, why introduce eventing? Why introduce orchestration when you just have a couple of services that just call each other? Maybe it's not so bad to have them call each other directly. On the other hand, if you have a lot of services that are not closely related, they are not executed in a certain order, they change frequently, they can exist in different kind of flows, then in that scenario, you want things to be flexible. And that's when I start thinking about event-driven architecture, because you want to be able to change things and you want to be able to kind of extend things. And that's when event-driven becomes relevant. On the other hand, if you have your services kind of closely related, they usually go together in a certain order, you have a business flow you want to capture, that's when you start thinking about orchestration. So make sure you ask these questions and try to see which one fits better for your use case. So that's number one. At the same time, you don't need to choose one or the other. You can kind of combine them. And one pattern I've seen is what I call event-driven orchestration. And in this event-driven orchestration, I have an example on GitHub. You can check out at this link. But the idea here is that, try to orchestrate things that you can. For example, like I have this image processing pipeline where I drop an image and then it gets filtered, labeled, resized, and watermarked and saved to a cloud storage bucket, right? So in this case, I need to call these services in this order: filter, label, resize, and watermarker. And I need to deploy these services in this order. So that's why I have that dependency between services, right? So that's why this is a really good use case for orchestration, because, even though these services are independent, they need to go in a certain order. So I put those into an orchestration. But at the same time, to trigger the orchestration, I'm using an event. So the user drops an event and a file into a cloud storage bucket. An event arc, which is a service on Google Cloud, routes that event to workflows, to orchestration. So I'm making that event-driven because it doesn't need to be tightly coupled to the user action, right? So here I'm using orchestration for things that make sense, but I'm making it loosely coupled with events. And similarly, maybe when the user saves the image, maybe I want to trigger another event to another orchestration, right? So make these ends loosely coupled, but then have the services tightly coupled with an orchestration. Second pattern is about retries and handling errors with retries and Saga pattern. So for example, let's say you have an order service and then you have a customer service that do different parts of a transaction. So the order service receives an order and it creates a pending order. And then the customer service, once you have a pending order, tries to reserve credit to make sure that the user has enough credit to pay for the order, right? Now, let's imagine this customer service is flaky. It doesn't work all the time. Sometimes, it times out, things like that. In that case, what you can do is you can apply a retry policy here. So when order service calls the customer service, it doesn't call just once. It can call one or more times that you define, right? So this retry policy lets you get over transient errors. So if customer service is down for, like, say, 10 seconds, maybe when you retry, next time it will work. So we'll get rid of transient errors. But then there's sometimes errors that are not transient. They're permanent errors. Let's say the user doesn't have enough money to pay for the order, so it doesn't matter how many times you retry, it's not going to work. So for that, what you need to do is like, so if the user has the credit, you need to approve the order. So you need to go back to order service to approve the order. But then if the user doesn't have credit, then you need to go through order service and reject the order, right? So that's the compensation step that you need to take. And that's what Saga pattern is about. It's about, looking at the transaction, which is an order that you need to process, that depends on two services. And depending on the outcome, either approve it or reject it, take a step back and reject the order. And I have an example here. I don't have that much time to show you this, but basically if you look at the orchestration definition, you can do this easily in workflows. Like you can create a pending order, reserve credit, and then as you are reserving credit, you can wrap that into a retry. So that does the retries for transient errors. But then if there's a permanent error, you can get into this except block and then call reject pending order. And then this reject pending order calls the order service with the order ID, and that's how you do the compensation step. So this kind of stuff is quite easy to do in workflows. All right, so another pattern is callbacks versus polling, I call it. So let's say you are going through your steps in your orchestration, but at some point you need to call some external service, or you need some external input. One way of doing that is to kind of poll the external service and wait for the external service to finish its job and say, okay, I'm good, So that's polling. But another way is to do callbacks. So you in your orchestration, you create a callback endpoint and let that external service call you back, right? And in my opinion, the callbacks are the better way of handling this. And I show you a couple of examples of how to do this in workflows. So if you can create callbacks and if you can get this external service call you back, try to do that. But if not, then you need to poll yourself and get some status from the external service. So that's how you can wait, basically polling versus callback, and try to prefer callbacks if you can. All right. Another pattern is parallelization. So in our steps, we have one step after another step, another after step, right? So it's like steps after steps, and it can make you think that these steps have to happen in serial, right? You need to wait for step A to finish before you can go to step B. But actually, you can parallelize these steps if they're independent. And I have an example again where I show you how you can run 5 queries that each take 20 seconds against BigQuery using workflows. So total, they take 100 seconds if you run them sequentially. But then if you parallelize them, because they're independent, they can take 20 seconds because they run in parallel. And again, this depends on the orchestration system you're using. But I'll show you how this is done in workflows. For example, here I have 5 tables that I want to query. And then here I have this run query step. And the key part here is this parallel. So here what I'm saying is that whatever is within this block, I want to run that in parallel. And I have this shared result variable where I want to say the results. Okay, that's how you share variables between branches. And then I have this for loop where we go through the table and run some queries against that table. So this for loop for 5 tables will happen in parallel. They each run in parallel, and then we save the results to this results table, and then we return that. So make sure you, if you can parallelize these steps, if they're independent, try to parallelize them so things they don't take too long. They can finish it much quicker. All right, another pattern is combining serverful workloads with serverless orchestration. So this orchestration stuff I'm showing you is all serverless. Like it's a service you use to orchestrate and run. But sometimes you need servers to do things. If you have a long-running job, for example, that needs to run for a long time, then you can't really use serverless functions or containers because they have limitations on how long they can run. Or maybe you need a GPU or you need a virtual machine with special settings, something like that. But one useful pattern is that you can use an orchestration service like Workflows to create a virtual machine with the configuration that you need to run that workload on that virtual machine to get the result and then to return the result. So what you're doing here is that you're using servers, so it's server full, but you are using workflows to kind of orchestrate that so that the user doesn't need to know that there's a server. So you're kind of making serverless out of service, basically. And I show you an example of this here if you're interested in seeing how this works. And similarly, again, if you have long-running batch jobs, there's things on Google Cloud, for example, Google Cloud Run job that can run jobs in containers in parallel. So you can do that in Cloud Run job. Then you can use workflows to orchestrate them. So you use workflows to kind of create these parallel jobs. And then you can use events to kind of start these jobs. So here a user drops a job description to a cloud storage bucket that triggers an event that goes to workflows. And the workflows reads that job description, then creates the number of jobs needed in parallel, let them run and save the result, right? So you're using the best tool for the best job. So Cloud Run job to run batch jobs, workflows to orchestrate it, and event arc to kind of make it loosely coupled to external systems. And again, I have a couple of samples here if you want to look in details of how this works. And finally, I have a couple more patterns to finish off. You can use GitOps to manage orchestration lifecycle. So the idea of GitOps is that you have some piece of code that you want to deploy in production, but we don't do that like straight from Git to production, right? What we usually do is that we deploy the code into a branch, then we run some tests against that code in staging. Then once we are happy, we merge that code into main branch, then run some tests against it again on the production environment. And then finally, if we are happy, we will update our production code with the changes that we had. Now you can apply the same kind of logic to your orchestration. Since we have this workflows.yaml definition, we can do the exact same thing, like deploy to staging, run tests against it, test it, deploy to staging, merge to main, so on and so forth, right? So this whole flow, GitOps, you can do it with orchestration. And if you want to look at the details of how to set that up, again, I have the link. You can check it out. And finally, you also need to plan for multi-environment deployments. Just like with your code, like let's say you want to deploy your code, you deploy in a testing environment, you call your testing APIs, and then you merge it to production to call the production APIs, right? So similarly with orchestration, what you don't want to do is you don't want to deploy an orchestration in testing environment, but call your production URLs. That wouldn't be nice because you're mixing testing and production, right? But instead, what you can do is that you can deploy your orchestration, and then you can pass in testing URLs. So that doesn't call your production services, but it calls your testing services in staging environment. And there's a couple of ways of doing this. You can author your workflows and pass in the URLs as runtime arguments. So you have a single orchestration definition, but the URLs that you want to call, they're passed in at runtime. So when you execute the workflow, you pass in the staging URLs, or you pass in the production URLs. So that's one way. Another way is you can author your workflows with placeholder URLs, and then you can replace these URLs before at deployment time. So you change at deployment time, you change the staging URLs, or you change it to production URLs. And you can do this either using Cloud Build, which is a build service of Google Cloud, or you can use Terraform to replace this. It's really up to you how you want to replace these URLs. But once these URLs are replaced, then you can deploy your workflows, and you will have two workflows: one more staging workflow that calls staging URLs, and one production workflow that will call production URLs. and then you'll execute those separately. I usually prefer this one because I like to have clear separation of work orchestration as well in production and staging. But it's really up to you how you want to do it. And again, there's a link to tell you in detail how to set this up. Okay, I think I'm up now because I already used my 30 minutes. So thanks very much for listening. As I said, if you want to get access to the slides, this is Speaker Deck. If you want to ask questions, I'm here. So feel free to ask questions. And if you want to reach out to me after today, this is my Twitter. So feel free to also reach out to me on Twitter if you wish. Thanks very much. I think you're...
Thank you very much, Mete.
Okay, I hear you now.
Thank
you.
You can hear me?
Yes, I can. Yeah.
Yeah, thank you very much for this widespread presentation of multiple service orchestration patterns. It was very, very nice and very complete. It's nice to have a lot of examples as well on hand to be able to illustrate each of the patterns that you disclosed today. Thank you for that.
And for all of them, I have GitHub links with details of how to actually set them up. So hopefully, if people are interested, they can go to those links and just check it out in detail.
So as I explained at the beginning of the tonight's event, we are now welcoming as well Olivier Leplus, who will be joining this small discussion about all the service orchestration patterns that you presented tonight, Mete. I have myself noted quite a few stuff I'd like to ask you, Mete, but maybe Olivier, if you want to go for the first one, I'd be happy to give you the stage first.
Well, thank you for the presentation first. It was very interesting, and I like that you mentioned all these design patterns, from the one that had very few pros, the first one,
yeah,
and to the one which is the more very cloud oriented. And I was wondering, and I was doing some research at some point, because the central orchestrator, what I see, you didn't mention in the cons, I guess, but is that you use a vendor locked product though. So I was wondering if there was any open source, cloud orchestration, so you can use, any orchestrator that you can move from on-premise, any cloud provider. Do you know that?
Well, yeah, that's a good question. Yeah, so if you use Google Cloud Workflows or Azure Logic Apps or AWS Step Functions, you're locked into the cloud provider, and that's true. But there's CNCF serverless workflow project that aims to be the open source service orchestration project, and you can run it like you can define it and run it locally. But it's not like you can define it and run it on Google Cloud and AWS and Logic Apps either. Even though it's open source, it's not like multi-cloud either. So I guess there's a way to kind of set things up. Like, I don't know, I haven't tried it like in detail myself, but there's probably a way to have a VM and run it on different cloud providers in a VM or something like that, or maybe in a container. I don't know. But there's no for example, there's no support in workflows, for example, to get this CNCF service workflow definition and run that in workflows. Yeah. And the reason for that is because even though they're similar, it's not one-to-one, right? So it's similar but not quite the same, and that makes it really challenging for CNCF service workflows to run in multiple places. So the answer is, there's an open source version, but you're kind of on your own to make that work in different environments.
Yeah, that's when you wonder, why didn't we sit all at the table and try to come up with a common DSL for serverless?
Yeah. And we did talk about, like, at Google, we did talk about like looking into that and see if there's a way to support it. Like maybe there would be a subset of that where we can run a subset of that on workflows. There were some discussions, but with the priorities and everything, it's not there. It's not like, I don't think there's anything in the short run for that.
Okay. Even if we had a common DSL on hand, I see a lot of people discussing about the if it is a good idea or a bad idea to put business logic, like for example, an orchestration workflow, into configuration.
Right.
And even if there were a common open source DSL language to provision all kind of various workflow orchestrator, I would still see people reluctant to actually put business logic somewhere else than the actual runtime code that is supposed to be executed for each of the tasks.
Yeah, exactly. That's a really good point. As we were, like, me and my coworker, you probably know Guillaume Laforge. He's also in sort of the stays.
He was with us
right?
last Tuesday. Yes.
Cool. Yeah. So me and him, we wrote a little application, like this was like last year probably, where we were doing things in functions. And then we said, okay, let's take this and try to do it in workflows and how that would work. So we would still do things in functions, but we would call it from workflows. And then we also extracted some of the logic in workflows, because in workflows, for example, it's very easy to make a call to a service, get the result, and check that result, like basic checks, not complicated checks, but like look at the JSON and see if this field is true, for example. You can do that easily. And then depending on that result, call something else, right? And we were always like kind of debating, like, should we do this check in the code or should we do this in workflows? I mean, it's easy to do in workflows, but does it make sense? And if so, like, when do you decide like what to do in code versus what to do in workflows? And I think there's no right answer, to be honest. But what we decided in the end is that, you know, if it's just like a one quick check, like one Boolean check, for example, then it ends up being simpler and easier to do it in orchestration definition. And it's not really the business logic per se. It's more like, you know, you're just doing a quick like Boolean check or quick string matching or something like that. But if it ends up being more complicated, then at that point, I think it's better to do it in the code and just call the code from workflows. And then over time, that's how we evolved our orchestration. Like we basically use orchestration just to purely call services and do these very basic checks. But then any kind of like meaty business logic ends up being in the code that doesn't get exposed in the orchestration because it doesn't make sense. And also it's harder to write code in YAML, right? you don't want to have YAML as your language of coding your business logic.
Yeah, that's for sure.
This workflow actually for CNCF, and it's JSON, not YAML they're using.
Yeah, is it? I thought it was both because I mean, same. By the way, same in workflows as well. Like in Google Workflows, it's both JSON and YAML. You can choose either. I usually go with YAML because it looks better in my eye. But I thought the CNCF was also.
Oh yeah, no. I mean, the samples are in JSON, but it says on the documentation that you can define in JSON and YAML.
Yeah. Because technically, all YAMLs are JSON anyway, right? So you can convert easily.
Maybe making sure that it's not a descriptive language like YAML or JSON, which is used to configure services, but a programming language like we start to see, for example, with Pulumi or the CDK by AWS. Or I even saw a lot of works done by an open source framework called Functionless by Sam Goodwin, who was actually trying to let people write TypeScript code and actually transpile this TypeScript operators and conditions to their equivalent in CloudFormation or any other descriptive language to give the illusion of having a cloud runtime, but it being actually transpiled to configure services. You would still be with a very familiar coding environment, feeling like you're actually writing code being executed by a function, but this would be transpiled, abstracted away, and provisioned as configuration over a service.
Yeah, exactly. And
lowers the bridge, lowers the gap between the.
Yeah, and that's one of the things that I told the product team over workflows is that I basically want to see a UI where I just drag and drop things, connect things, and then the YAML gets generated, and I don't have to even think about it because really, like, YAML is not something we should write in, especially this kind of logic. Like, it should be generated. So whether it's generated from UI or whether it's generated from some high-level kind of language, that's a matter of taste, I guess. But I definitely agree that like it should be like generated, and it's something we want to do. And actually, I think Logic apps, Azure Logic apps, they do that. You can visually kind of build your orchestration. So some cloud providers, they actually provide that. We want to provide it as well at some point. It's just a matter of priorities, like, and what's more important. Like not right now, they're trying to fill the gaps of the product, make sure that it does what people need. And then I think next phase will be to kind of build on top of that to make it easier with UI and maybe a high-level language instead of YAML. Yeah.
Speaking of definition, whether we use like today YAML and JSON and maybe at a stage a drag and drop interface or programming languages, you said at the beginning of the talk that orchestration pattern or communication pattern are there to orchestrate multiple pieces, like multiple microservices. If you have to put at some point an orchestration workflow that is covering multiple microservices, who would be the owner of the definition of this workflow? Which microservices should be the one encapsulating which other microservices to call? Do you have a strong opinion on that?
I don't know.
Depends on the context.
Yeah, exactly. Like, yeah. I mean, I'm not sure, like, to be honest, who should own. Yeah, I mean, yeah. Exactly. Like, I mean, how do you? Yeah, how do you define these orchestrations, where they live, and who owns what, and how do you? I mean, right now, for example, in Google Cloud, you just define these orchestrations in a single place, but it's not so clear, like, who owns them, right? Like, who triggers these workflows, and how do you make that obvious? There's no, right now it's not so clear, to be honest. I mean, you can, I think you can label these workflows, so maybe you can use labels, and then with those labels you can match it to whoever triggers them somehow. But maybe we need more controls around that, because right now it's just basically here's an orchestration. If you can reach to it, you can trigger it. There you go.
Yeah. Okay. Yeah, the Yantri, I believe, an AWS Server Zero had a strong opinion on this, saying if you're working between microservices, always go for choreography with events, which allows you to be completely loosely coupled and to have reactive microservices to something happening in another microservice. And within the bounded context of a microservice, use orchestration as much as possible to coordinate the various tasks that you have within the same microservice. The examples that you showed earlier with the resizing and watermarking the image.
Well, I guess it depends what they call microservice then, because in here, like the orchestrator is calling multiple microservices, right? And you are kind of bringing them together into a single unit that you call orchestration. So I don't know what it means to have orchestration within a microservice, like, like, because with a microservice is basically like a function or maybe like a container or something like that. So how do you have orchestration within that? I'm not sure. Usually it's the other way around, where you have multiple functions and you want to kind of bring them together into a unit, and that's when orchestration comes into a picture.
Okay.
But I like this picture of, like a combo of event and orchestration.
Yeah,
it's pretty interesting. Yeah,
it is, because the thing is, you don't want to make things tightly coupled if you don't have to, right? So, for example, you have an orchestration. You know that these things should go together, but does that orchestration need to be called in a tightly coupled way from front end? Probably not, right? Like, so then if that's the case, then why not send an event and let it trigger by an event? That will allow you to change things much easier.
And if we have some parts which are event-driven in this overall process, do you have some countermeasure to still have a common place where you can look at where you are among all the different task of your workflow if it's not a complete workflow and you have a broker in between some location? Do you have some countermeasures for that?
Yeah. Well, not really. So I think what you mean is, let's say you trigger an event, it goes to an orchestration runs a bunch of services, and then that triggers another event, and then something goes wrong, and then can you see it in a nice dashboard? I wish.
To understand where it went wrong.
Yeah. If something went wrong, I wish it just told me, oh, this event didn't get triggered here, so go and check here. I wish, but no, we don't have that, unfortunately. And
even replay events.
Yeah, exactly. Yeah. I mean, I think that's the problem with like all the systems that we have nowadays, is that they do their own parts, but then you need to integrate them together, which we do. But then when you need to monitor them, there isn't a single thing that monitors them all. So you either have to kind of insert your own monitoring somewhere, like you use something, like you use like a library or something somewhere, try to do your own monitoring, or you don't get this end-to-end monitoring, basically, and then at that point you have to kind of guess, okay, what is not working? Okay, you look at the orchestration. Did it work? Yes, the whole orchestration works. Okay, then you rule that out. Then from there you look at events. Okay, did this event fire? Yes. If no, then maybe this is where the problem is. So yeah, unfortunately, there's not a great answer there.
Yeah, you have to guess.
Like a tracer.
Yeah. Yeah, so we need a Uber tracer, basically, that traces all over the services that you have in all cloud providers. And yeah, maybe that's a good idea to try to work on something like that.
Have like a very good logging strategy, and then you can build your own tool, like a dashboard tool based on your logs.
Yeah, I mean, it's not just logging, right? I mean, the logging is good, but it's like it's so tedious, though, isn't it? Like when you need to figure something out, you have to still know where to look, and then you have to get in there and look at it. What I mean is that the orchestration fails right now. You see the exact step it failed. I wish that there was a way to kind of get that kind of certainty in all the systems where you're running your architecture. I don't think we have that today.
Imagine the support team who has to replicate a bug in there.
Well,
right? From start to end.
And yeah, my first job out of school was basically a support engineer, and I remember many days where 90% of the problem was basically tracing exactly where things failed. And once you know that, then the rest is quite easy to figure out like what the problem is. But tracing was like such a big problem, and I think it still is, right?
Yeah, especially when you have like an event strategy. I mean, these kind of strategy were very, asynchronous. It becomes very hard to. And as you mentioned, I mean, architecture becoming bigger, and yeah, every one of the of these steps has to communicate with the next one, and it's pretty hard to log that and to trace that.
Yeah, and then the thing is, for example, in the example I showed, you can visualize the orchestration part, which workflows has, great, but you can't visualize the rest of the stuff. Mm-hmm. And that's the missing piece. Like since you can visualize it, you don't even know what the architecture looks like, unless there's like really good specs you can go and read. But usually, like when you go and see the specs, they're out of date, and the person who wrote the spec is long gone. So
you send a message to the whole company. Who knows the entire architecture? Like, well,
yeah, and the problem is, yeah, exactly. Things are so complex nowadays that nobody even knows like the whole architecture anymore. Anyway, so yeah.
I did not another question related to orchestration on a separate topic. How do you recommend to handle long-running orchestration? For example, where you'd have 5 waiting days because you need to legally wait for 5 days. Because you mentioned versioning as one of the pros of having orchestration.
Right.
But there are some situations where you actually want to migrate your orchestration workflow, your definition of the workflow, to the new version, including the currently in execution workflows that you have in your application. What do you have to handle this kind of situation?
Well, first of all, the workflows can run up to 1 year. So if you have a workflow, it can run up to 1 year. So that's usually not the problem. The problem is usually what the workflow calls. and they all have their own timeouts. And those timeouts are all different. Like, for example, Cloud Functions has timeout of, I think, default 10 minutes, but you can change it up to 60 minutes. So it can run up to 60 minutes. Then Cloud Run, same, like 60-minute timeout. But then I think Cloud Run jobs, they have longer timeouts now. So the challenge I find is basically trying to figure out, like, if I'm given an orchestration, I know that the whole orchestration can run up to 1 year, but I'm not sure if each piece can run and how long they can run. So I have to always go and check what I'm calling and what their timeouts are, and whether those timeouts are set properly if I want to run something long running, you know. So that's one. And the second thing is, I think what you're asking is like basically live migration. Like, you know, in Google Cloud, there's this awesome feature on virtual machines. If you have a virtual machine running and it needs to update its OS, I think, it can live migrate and the workload and do the update, and then the user doesn't realize anything, which is great. But we don't have that kind of live migration for orchestration. So if you need to update your orchestration, you basically deploy a new version, and your existing orchestrations that are running, they will continue running in the old version. And you either wait for them to finish and deploy with the new version, execute with the new version, or you just cancel them and then re-execute them with the new version. But there's no like, okay, I'm running this orchestration, let me kind of
switch
update
to this
the version. Yeah, it doesn't work. It would be really cool, actually. Let's say you're running your orchestration to this step, and then you add a new step, and if it could somehow recognize it and just say, okay, fine, I'll run this next step too, because it doesn't interfere with anything I already run, you know. It would be cool to have that. We don't have that today.
Okay. And so if you have very long process due to business reasons, you should rely on another mechanism to handle those waiting period or those callback that can take days to avoid getting stuck in an old system.
Yeah, I mean, as I said, like the workflow can wait for like a year. So as long as it finishes within 1 year, it's okay. Yeah. So what you would do is that basically you would create a callback in workflows. There's an API call basically that says create a callback and wait on the callback, and then you save the callback somewhere so that the external system knows what to call back, and then the external system will do its work, and then it will just call back to your orchestration when it's done. So as long as that happens within a year and within the callbacks timeout, because the callbacks also have their timeouts, then things will be okay.
Okay. Another question also, not related at all to what we just discussed. In your Saga pattern, you mentioned the failure and remediation workflow. Do you distinguish technical failure, like my previous task timed out, to business failure, like you don't have the reserved amount that you want to do this order? And do you have separate remediation step? Do you need to take into account both, like everything that can fail, technically speaking, and everything that can fail on the business levels?
Right. Yeah, I mean, it really depends on the semantics of your application and what you consider like a transient failure, what you consider like a permanent failure, recoverable failure, stuff like that. In the example I showed, for example, I forgot the HTTP code, but I basically said, okay, if it's HTTP code, this and that, then I consider this as a temporary failure. And if you retry next time, it might work. So I handle those as like retries. But then if the user doesn't have credit, then there's a certain HTTP code that gets returned. So I interpret it as that's a permanent failure because the user doesn't have credit. So it's not something I can retry. It's a failure. And then at that point, I treat that as something I need to actually take a compensation step for, because I created an order. So I need to go back to that order, and I need to change that order from pending to cancel because the user doesn't have credit. So that's the Saga pattern and the compensation step. So yeah, it really depends on on your app, what failures you have, how you return them, and then capture those in orchestration and handle them accordingly.
Okay. Thank you very much for the answers.
Yeah.
Yeah, so
That's all my questions.
Yeah, there's a lot of things that
I'll
are
go ahead and
easier
answer.
with microservices and serverless, but I mean, as you mentioned, it adds a lot of things to consider too, like error handle and debugging, and as you mentioned, when it's technical failure or it's a business failure, all these.
Right.
Even though it's easier to work with like small programs and microservices, there's a lot of complexity that is added to it because of this.
Yeah, I mean, you're talking about like monolith to microservices discussion, right?
Yeah.
Yeah. I mean, that's a whole different discussion where now people are saying that okay, maybe we shouldn't do microservices because like there was one article that said Amazon they switched from back to monolith and they saved so much money. To be honest, I think it all depends on the context again. Like it's like I've seen cases where actually like monoliths they helped because it really you reduce things into smaller pieces and then you can reason about them, you can update them easier, and teams can work on microservices and they don't have to care about other teams. So there's benefits definitely. But I also seen cases where people just did microservices just because everyone is doing it, and then in the end they ended up having this distributed system that no one knows how to maintain because it's like event driven, events are flying and no one knows like how to monitor them properly. So it all depends on what you're doing, how you're doing it. I don't think there's like one answer to like one is better than the other. There's good ways of doing microservices and there's bad ways of doing it. And there's also the same with like if your application is small enough, maybe it's good to do it in a single monolithic application, and maybe that's good enough for you. Why not? But if you need to scale different parts of your monolithic application, then you don't want to scale the whole thing. It's going to be expensive. You want to break out and then scale the parts that you need. So yeah, basically, there's no right answer, I think.
Yeah, it's always important to know the trade-offs that you're making, but you will always make trade-offs. Yeah,
exactly. Yeah, it's all about trade-offs. So it's realizing those trade-offs and making those in a conscious way. Because I keep emphasizing that because I don't know, maybe it's the places I work, but I've seen where things are just decided like without really any without documenting it or without like any conscious effort. It just happened, and then we're stuck with that. That's the worst place to be. So make sure that you actually consciously thinking about these things and deciding on them.
that's for sure. Wise advice. Thank you very much for those words, Mete.
Thanks.
We're getting close, or we're getting past this 1 hour session of the Warm session, but it was very nice to discuss the subject, and I didn't see the time fly away.
Yeah, I know. Thanks very much. Like I really like the format of like presentation and discussion. It really makes it nicer, I think, for me for sure, but hopefully it was also nice for everyone else.
Yeah, it was nice for us as well. It was always nice to discuss the subject after a good presentation. Thank you very much for your time and for your presentation.
Yeah, thanks for having me, and good luck next week at the conference. Hopefully it's a nice conference for everyone.
Yeah, it will be a very nice conference. Just a quick reminder. So next week, Wednesday, 7th of June, Thursday's main event in La Bellevilloise, Paris 20th district. All the information are on paris.serverlessdays.io, and there are still tickets up for the grab. So please join us if you want to learn more about serverless. It will be an amazing day. Thank you, Mete. Thank you, Olivier, for your participation. And I see most of you guys next week.
Cool. Thanks very much. See you.
Bye.